Alright, so this will be the hazardous materials training for all Go Cross employees. The lesson objectives are to identify types of hazardous materials and how exposures can occur, identify hazards associated with hazardous materials, including injuries that may occur, describe methods for eliminating physical hazards or hazardous materials, describe methods for eliminating health hazards of hazardous materials. So what's in it for me or you as an employee? Hazardous materials in the workplace can cause severe health problems and or physical injury to the worker. Employers have the responsibility to anticipate, recognize, evaluate, and control hazards associated with hazardous materials in the workplace. Hazard abatement must be accomplished through a hierarchy of controls. Hazardous materials can unexpectedly be brought home to a worker's family, causing an illness. And again, a lot of this won't really apply to our day-to-day work, but we go into many different industries and workplaces where you need to be aware of this type of information so that you can respond appropriately. So, what is a hazardous material? A group of products which the storage, handling, and use are regulated under the hazardous materials standard. Primarily associated with physical hazard, may also pose health hazards. So this can be anything from compressed gas to hydrogen to oxygen, flammable liquids, flammable materials, and other types of chemicals or things that could cause hazardous material exposure. Examples of hazardous materials in the workplace. In the workplace, exposure to hazardous materials may come from the manufacturing, storage, or process that uses or creates a situation as defined by the NFPA as being a hazardous classified location. OSHA standards 29 CFR 1910 subpart H lists requirements of the following situations, all of which have the potential to expose employees to hazardous materials: the proper use, storage of compressed gases, the proper use, storage of flammable liquids, spray finishing operations using flammable and combustible material, storage and handling of liquefied petroleum gases, the process safety management requirements of highly hazardous chemicals, the work associated with the hazardous waste operations and emergency response, dipping and coating operations. So, in the workplace, exposure to hazardous materials may come from the manufacturing, storage, and or process that uses or creates a situation as defined by the NFPA as being a hazardous location. So there's, again, 4 different categories of flammable liquids. We deal mostly with oxygen, and they're cryogenics and refrigerated liquids, which is oxygen and nitrogen, argon, hydrogen, helium, as well as others, and then LPG or liquefied petroleum gases. Exposure to hazardous materials, you may have it again with spray finishing products, dipping and coating operations, processing of high hazardous chemicals, cleanup and management of hazardous waste operations, and emergency response. Additional precautions for hazardous exposures, the classified location and confined spaces as well can present different barriers or issues with hazardous materials. So routes of entry can be inhalation, so breathing it in, ingestion, swallowing it, absorption through the skin, or an unexpected injection. Inhalation being the most common of the routes of entry for hazardous materials. So types of physical hazards associated with hazardous materials. So these are your associated different types of things that the chemical itself will do. It can be an oxidizer, maybe flammable, explosive, corrosive to metal, or be in a high pressure system like our oxygen cylinders. So types of health hazards. So a health hazard means a chemical which is classified as posing one of the following hazardous effects: acute toxicity, any route of exposure, so any of the 4 routes of exposure that we talked about previously, skin corrosion or irritation, serious eye damage or eye irritation, respiratory or skin sensitivity, germ cell mutagenization, carcinogens, reproductive toxicity, specific target organ toxicity, or aspiration hazard. For the purpose of this lesson, the following health hazards will be discussed: acute toxicity, skin corrosion, irritation, and aspiration hazard. So when looking at how things are labeled. The skull and crossbones mean acute toxicity. The exclamation mark means it's a skin or eye irritant. A health hazard or a carcinogen is going to look like the man in the center there with the exploding heart. And then corrosion, skin corrosions are going to be your two little vials there that are being poured onto the hand in the metal. Hazards of, again, continued hazards of hazardous material. Compressed gases. Hazards associated with compressed gases include oxygen displacement, fires, explosions, and toxic gas exposures, as well as the physical hazards associated with the high pressure systems. Special storage use and handling precautions are necessary in order to control those hazards. Gases under pressure are gases which are contained in a receptacle at a pressure of greater than 29 psi or more, or which are liquefied and refrigerated. So our oxygen cylinders classify as gases under pressure. Cylinders of compressed gases and cryogenic liquids can be extremely hazardous if misused. Besides the hazards associated with high pressure, the chemical hazard of cylinder contents must be considered. In addition, some of these materials, especially the cryogenic fluids, are extremely cold when released. Certain precaution must be observed in storage, handling, and use of these materials in order to minimize the hazards. So, cryogenic and refrigerated liquids, those are the ones that are going to be extremely cold, have extreme pressure, risk for asphyxiation if exposed to it, and have a high potential to have a fire explosion if not handled properly. So flammable liquids mean liquid having a flash point of no more than 199.4 degrees Fahrenheit. Flash point means the minimum temperature at which a liquid gives a vapor in sufficient concentration to form an ignitable mixture with air near the surfaces of the liquid. Flammable liquid can be classified in one of four categories. A flash point between 73 and 95 degrees, a flash point between 73 and 95 degrees, and then flash point 73 between 60 and 93. So different types of categories that you're going to see. So spray finishing, flammable combustible materials, they have health hazards. So the particulates that are inhaled if not proper PPE is not worn, and some actually may have caused inflammation of the skin or issues with absorption in the skin as well. LPGs, so liquid petroleum gas, you're going to see the flammable and the compressed air pictogram. The signal word is obviously danger with these hazardous statements. Extremely flammable gas, contains gas under pressure, may cause frostbite, may form explosive mixtures in air, may displace oxygen and cause rapid suffocation. So you're going to see those associated with compressed natural gas. So, ammonia is not strictly speaking a poison, and repeated exposure to it produces no additive effects on the human body. However, even a small concentration in the air can be extremely irritating to the eyes, throat, and breathing passages. Ammonia can primarily affect three areas of the body: eyes, lungs, and skin. Exposure to ammonia vapor may cause convulsive coughing, difficult or painful breathing, pulmonary congestion, even death in high concentrations. The odor threshold for ammonia is between 50 to 50 parts per million of the air. The permissible exposure is 50 parts per million average over an 8-hour shift. It is recommended that if any employee can smell it, they ought to be back off and determine if they need to be using respiratory protection. Ammonia is a chemical structure made out of nitrogen and 3 hydrogen atoms. The main cause of its acidic odor is the nitrogen. It can be found also in some cleaning products, cat urine, and then sometimes human sweat. So that ammonia is used a lot in liquid refrigeration. So one of the large liquid refrigeration places that we go to will use ammonia. So in extreme circumstances or a cracked pipe, you might have a large ammonia exposure that you may respond to. So there's the classifications of hazardous materials or the flammable gases. Class 1 are those in which flammable gases or vapors may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. So depending on where the stuff is stored, is dependent on the actual classification. And then Class 2 is a combustible dust, and Class 3 is ignitable fibers or filings. Confined spaces. So confined spaces contained that are considerable because when they are not necessarily designed for people, they are large enough for workers to enter and perform certain jobs. A confined space also has limited or restricted means for entry or exit, is not designed for continuous occupancy. So confined spaces are limited to, but not all-inclusive with this list: tanks, vessels, silos, storage bins, hoppers, vaults, pits, manholes, tunnels, equipment housing, ductwork, pipelines. OSHA uses this term, permit required confined space, to describe the confined space that has one or more of the following characteristics: contains or has the potential to contain a hazardous atmosphere, contains material that has the potential to engulf an entrant, has walls that converge inward or floors that slope downward and taper into a smaller area, which could trap or asphyxiate an entrant, or contain any other recognized safety or health hazards such as unguarded machinery, explosive live wires, or heat stress. So if you see the term confined space, that's what that means. Again, we really shouldn't be entering confined spaces without assistance from our local hazardous materials teams, our fire department, as they're trained in extrication of patients out of these areas. So controlling physical hazards, there's a hierarchy of controls. Controlling exposure to occupational hazards is the fundamental method of protecting workers. Traditionally, a hierarchy of controls has been used as means of determining how to implement feasible and effective control systems. So there's 5 different ways to help limit your exposure to physical and chemical hazards. Again, elimination and substitution, obviously eliminating that product or substituting for something else. So engineering controls, PPE for controlling existing worker exposures. Well-designed engineering controls can be highly effective in protecting workers and will typically be independent of worker interactions to provide this high level of protection. And then administrative controls and PPE. So making sure you're wearing the proper protective equipment. Always default to an industry safety team when you arrive on scene of a large industry to determine what the most appropriate PPE is for that certain situation. The WPAC Foundry is a good example where you need to wear hard hat and glasses upon entry. So refer to the safety team at the location that you arrive at to help guide what type of PPE you will need to wear in order to access your patient. Compressed gases. Compressed gas cylinders should be in a safe condition to the extent that it can be determined by visual inspection. Visual and other inspections of compressed gas cylinders shall be conducted in accordance with hazardous materials to the Department of Transportation laws, Compressed Gas Association pamphlets. General guidelines for compressed gas cylinders. A cylinder should always carry a legible label or stencil identifying the contents. Do not deface or remove any markings, labels, decals, tags, or stencil marks used for identification of cylinders' contents. Empty cylinders and cylinder storage areas should be clearly marked with appropriate labels and signs. Assigned storage space should still be located where cylinders will not be damaged by passing or falling objects or subject to tampering by unauthorized persons. Cylinders should not be kept in unventilated enclosures such as lockers or cupboards. Ensure cylinders are stored and used in a dry, well-ventilated area. Cylinders should be stored outside of direct sunlight and heat. Do not tamper with the safety relief device in the valve or cylinder or attempt to repair or alter a cylinder valve or safety relief device. Cylinder valves should be closed at all times except when cylinder is in active use. Cylinders of oxidizing gases, including oxygen, except those on a welding cart that is used on a regular, must be stored at least 20 feet away from any flammable gases or separated by 5 feet high, 30-minute minimum fire-resistant wall. Oxidizing gases also must be stored away from combustible materials. Not something we really have to worry about at Gold Cross, but good information to have, and we do store them in appropriate areas away from all of this type of material. Safety cans shall mean an improved container of not more than 5 gallons capacity, having a spring closing lid and spout cover, and so designed that it will safely relieve internal pressure when subjected to fire exposure. Cabinets, maximum capacity not more than 60 gallons is a Category 1, 2, or 3 flammable liquids. No more than 120 gallons of Category 4 flammable liquids must be stored in a storage cabinet. Extinguishers, suitable fire control devices such as a small hose or portable fire extinguisher shall be available at locations where flammable liquids are stored. Ventilation. Category 1 or 2 flammable liquids or Category 3 flammable liquids with a flash point below 37.8 degrees Celsius or 100 degrees Fahrenheit shall be ventilated at a rate of not less than 1 cubic foot per meter per square foot of solid floor area, usually accompanied by a natural or mechanical ventilation with discharge or exhaust to safe location outside of the building. Provision shall be made for introduction of make-up air in such a manner as not to short-circuit the ventilation. Ventilation shall be arranged to include all floor areas or pits where flammable vapors may collect. Again, not something we typically have to worry about, just to be aware of when you're responding in areas that may have flammable liquids, or you see that flammable liquid placard in certain industries. Explosion-proof apparatus enclosed in a case that is capable of withstanding an explosion of specified gas or vapor that may occur within it and of preventing the ignition of a specified gas or vapor surrounding the enclosure by sparks, flashes, or explosion of the gas or vapor within, and that operates as such an external temperature that it will not ignite a surrounding flammable atmosphere. Grounding, grounding of certain things may be necessary, and you may see this. Category 1 or 2 flammable liquids, Category 3 flammable liquids with a flash point below 100 degrees Fahrenheit shall not be dispensed into containers unless the nozzle and container are electrically interconnected, where the metallic floor plate on which the container stands while filling is electronically connected to the fill stem, or where the fill stem is bonded to the container during filling operations by means of a bond wire. The provisions of this section shall be deemed to have been compiled with. Grounding eliminates a difference in static charge potential between conductive objects and ground. Although bonding will eliminate a difference in potential between objects, it will not eliminate a difference in potential between these objects and Earth unless one of these objects is connected to Earth with a ground wire. So a way to prevent unexpected explosions or igniting of these flammable liquids when they're being filled. Intrinsically safe and apparatus equipment in which all circuits in which any spark or thermal effect is incapable of causing ignition of a mixture of flammable or combustible material in air under prescribed test conditions as described. So something that deemed intrinsically safe is typically has enough controls in place in order to prevent it from igniting. Again, looking at the hierarchy of controls, controlling health hazards, elimination or substitution controls can be accomplished by transitioning to safer chemicals. So engage, do an inventory, prioritize, identify, assess and compare, select, test, and evaluate is a good way to evaluate the efficacy of the chemical that you're using. Engineering controls can change process to minimize contact with hazardous chemicals, isolate or enclose the process, use of wet methods to reduce generation of dust or other particulates, general dilution, ventilation, use fume hoods. So a good example of this is with our when we fill up a gas, there's the valve in there in order to prevent the fumes from escaping. A good example of that, of an engineering control. Administrative controls, so rotating job assignments, adjust work schedules so that workers are not overexposed to hazardous chemicals, establish and enforce safe work practices, train your employees. And then PPE, we know about PPE from our previous training, but there's certain types of PPE that you're going to want to wear depending on what type of chemical or hazardous material you're dealing with. Again, default to the industry safety team in order to determine what is the most appropriate PPE when responding in and trying to gain access to a patient. Process safety management of highly hazardous materials. Hazardous chemical releases pose a significant threat to workers. The key provision of process safety management is process hazardous analysis, a careful review of what could go wrong, and what safeguards must be implemented to prevent releases of hazardous chemicals. Hazardous waste operations and emergency response applies to employers and their employees who are exposed to hazardous substance and are engaged in several operations, including cleanup, treatment, storage, and disposal of hazardous waste. So this is an example of when the fire department's hazmat teams, either Oshkosh Fire Department's or Appleton Fire Department's hazmat team is called in. And again, we're going to default to them as they're the subject matter experts on how to respond and treat our patients. And they'll be kind of the guiding force behind a lot of the things that we do on the scene of hazardous materials exposure. So again, defer to the experts on either the healthcare, the safety teams within that industry or the fire department's hazmat teams whenever responding. You can also refer to our MSDS sheets, which are located on our tablets or on our website. So there's lots of resources to you available to you as an employee that you should be able to access from the tablet on the in the ambulance themselves. If the work involves many different or complex processes, a person may need to help conduct job site evaluation and personal exposure monitoring. Sources of help include insurance companies. So we work with our workman's compensation company to help monitor our safety and ensure that you guys aren't exposed in unsafe manners in our industry. Our safety committee works well as well to ensure that we are constantly evaluating our job and the locations in which we work. Even when outside help is received, it is important that all employees remain involved in the process of identifying and correcting hazards because job site conditions change every day. We all know that. New circumstances and recombination of existing circumstances may cause old hazards to reappear and new hazards to appear. In addition, employees must be ready and able to implement whatever hazard elimination and control measures a professional consultant recommends. Thank you.